Welcome to today's webinar, where we will explore a groundbreaking technology and innovative company. I'm Sadettin Avcılar, your host for this presentation. Let me introduce you our guest, Appear. Appear is a leading provider of media processing and delivery technology. Headquartered in Oslo, Norway, with customers in over 100 countries. Appear provides the backbone that production companies, telcos, and broadcasters rely on to make immersive live experiences possible for their viewers. With world-class products and expertise, Appear's focus on modularity, efficiency, and high quality helps customers stay ahead of competition in a market where expectations and requirements are constantly changing and evolving. In today's webinar, Appear will give us some more insights on some aspects of live production and distribution over IP, elaborating on some key aspects and market intelligence on future media workflows. Profen is Appear's distributor and representative in Turkey and our surrounding countries. Connect with their representatives and discover how Appear can help you transform your business. Our webinar is titled Live Production and Distribution over IP. Our experts will also discuss two important topics: future of media workflows and back on-prem for live OTT transcoding. Our guest participants are Roel Dedecker, Business Development Manager of Appear, Mikhail Zavalin, Senior Technical Sales Engineer, Roel Dedecker, Technical Sales Engineer. I'm going to give the word to my friends in Appear. Roel, it's over to you. Please start your presentation. By the way, I want all presenters to talk their career and backgrounds before their presentations. Thank you.
Yes, hello, good afternoon. Thank you, Sadettin, for this nice introduction. It's really great to be joining the Profen Tech Days. So thank you very much for that. So yes, I think we have a few interesting topics we want to talk about today. Let me first introduce myself. So my name is Roel Dedecker. I'm a business development manager at Appear. I've been at Appear for around 2 years, and have been working in the media and broadcast industry in various roles and companies for the past 20 years. Maybe I shall just start with putting Appear a little bit on the map for a few minutes before we go into dive into the topics of today. Let me quickly share my screen. Can you see my screen?
No, you couldn't share, Roel.
Okay, sorry.
Let's try again.
But again, share. Now?
Okay, it's coming.
Good. Is it in presentation mode?
No, you can please make it on presentation mode.
Yeah, now it should be. Okay, there is some delay in the workflow here. So yes, let me, for the people who don't know Appear very well, Sadettin, you already mentioned some of the things, but yes, we are a Norwegian company headquartered in Oslo. We are a global leader in high capacity solutions for media processing and delivery, and we are working with many of the largest brands in the industry, both on the production side and on the broadcast and telco and distribution side. Appear was founded in 2004 by a couple of former Tenberg television employees. We are around 200 employees at the moment, spread out over 13 countries around the world. And yeah, I don't know, we have some over 100 customers in 100 countries across the world as well. Our solutions and development is taking place in the headquarters in Oslo, and also production of our products are over there. So we are working with content owners, production companies, broadcasters, head-end operators, telcos, to help them with their media processing and delivery needs. That's on a very high level what we are doing. If you look at the different segments that we are serving from left to right, so starting on the contribution and production side, we do have solutions that support customers for live event contribution. Nowadays, also a lot remote production, right? Because more and more of high-level live, mainly sports production is done more and more remote. But also for inter-facility one, so connecting different production facilities of production companies and broadcasters, and then also primary distribution. So the focus is on prime live contribution, mainly for high-profile sports and often in high-capacity environments where you really have a large amount of cameras that need to be processed and transported. So as you see on the bottom of the slide, we have three product lines. We have our X platform, and that platform is tailored towards the contribution segment that I just described. Then we go to the linear and OTT distribution, where we do have our XC platform, which you see on the bottom of the right side of the slide. That is mainly designed to cater for the needs of those applications. And there we're looking into head-end distribution, hospitality or business B2B television application, as well as live OTT transcoding, which is done by our Neo series, which is actually the latest product in our product lines, which is our dedicated appliance transcoding platform. And Twelve will talk a little bit more about that platform later on. So combined, we are using these platforms to cater to the needs of our customers, and that is really giving our customers a multi-service platform that basically provide everything that they will need today and in the future, as well to cater for their production and distribution needs. I'm not going to go into details. I really encourage everyone to take contact with either Profen or a peer, or look at our website to find out exactly what these products are doing more in detail. So on a high level, I would say the value that we bring to our customers with our products are power efficiency. We have one of the most efficient power efficiency platforms on the market. We can back that up, right, by some of our large service provider customers that have done some benchmarking studies on that. So if someone is interested in that material, we can share something about that as well. High density, multi-service platforms, future-proof, meaning that as a peer is following the standards in the market, future standards will be implemented on our platforms, and also the evolution of existing standards will be implemented. So customers that are investing in a peer are really safe for the future, and they will have a platform that will grow with their needs. And last but not least, it's reliability. Feedback we have from a lot of our customers is that peer products are really reliable, and obviously they should be, right? If you in the TV broadcast world, you don't want to see any black screen, so reliability is of course important. So how do we back that up? We want to be a lifetime partner for our customers and our partners that we work with, like Profen, because investments in a peer infrastructure is often a very long-term investment. And we back that up with our R&D capabilities, right? Because if customers buy an peer or invest in an peer platform, they actually invest in as well as in the R&D capabilities of a peer. 66% of our workforce is working in R&D, so that is also what customers get when they buy a peer. And obviously, last but not least, our support and professional services capabilities. So now I will give the word to my colleagues, Mikhail and Twelde, to dive into the topics of today, and they will present themselves as well. So Mikhail will talk a little bit about, the future of media workflows, evolution and challenges, but also, what are the relevant standards and how are they evaluating? And then secondly, Roel will take care of the topic back on-prem for live OTT transcoding, where he will share some data, market data, and also talk about a customer case in that area where we address, let's say, the needs of live transcoding on-prem with our Neo transcoding solution. So now over to you, Mikhail.
Yeah, thank you very much, Roel, for introduction. So my name is Mikhail, and more than 3 years I'm working for a peer. I'm doing technical pre-sales and mainly in Europe. So I have more than 10 years experience in the pay TV industry, was working on different roles, doing deployment and projecting the systems for the biggest customers around Europe. So, and the last 3 years is very interesting in Appear with the technology shift and new technologies being adopted by the industry. So if you can see my screen, can you confirm, please?
Yes.
Okay, then today I would like to talk more about technology. So
before beginning, I have a question, personal question.
You have a question?
You are visiting countries for sales and technical reasons. How many countries did you visit now? Have you been now?
Sorry, can you repeat your question? How many countries?
How many countries did you visit now? I saw a map at the background.
Yeah. I mean, there is a map. I think it's around 30, 35 countries. Not maybe the longest list, but still quite many to visit.
Okay, thank you. You can begin.
Yeah. Okay, so I would like to today. I would like to talk more about the technology. So I would like to cover a little bit of the media network evolution. So how we come to what we have today, what kind of challenges we see our customers having today. What is to SMPT 2110 in a nutshell, in essence. Sorry. I will talk about the NMOS. What is NMOS? Why is it, I do believe, important? I also make a little bit deeper dive into the ISO 4, ISO 5 parts of the standard, NMOS standard. And if we will have time, there's some bonus slides I would like to show you. So then straight to the history. Starting from 90s, our media networks were mainly using the dedicated standards like SDI, ISI to carry the uncompressed or compressed videos. Moving forward, the industry suggested to use a family of the 2022 standards to carry the compressed video over the IP using UDP and RTP protocols. These standards are still widely used today, and it's super successful, super popular. But the network keep evolving, keep progressing. So at the moment, it became possible to carry the source quality video, and then the industry came up with what is called the 2022-6 standard, which allowed to carry uncompressed video feeds over the IP network. Sounds nice and cool, but then the standards also had some disadvantages, and it developed further to address the modern challenges. And then SMPT 2110 was introduced to address the new technologies, including the UHD and HDR, in order to address the new customer workflow, new broadcast workflows, including the remote production, and to make it available, in order to make it available to outsource some of the functions, and also to make it possible to use cloud workflows. So if we have a look on the typical broadcast workflows, or kind of a map, what our customer is doing. So we are, and up here, focusing a lot on the sport production. So I put on the slide kind of a venue where the production is happening, and many cameras can be installed. So it's very kind of tier 1 event. Then the signals are carried to the remote studio or the MCR. And as you can see on the pictures in the bottom, some of the functions are either managed remotely or they sent to the cloud. And then on the right-hand side, you have a final contribution, so-called, when the ready-to-use signals are handed over to the distribution chain and the different chains. So the typical challenge is having all these multi-channel infrastructure on site will require a lot of cabling and a lot of space. And it's actually today it's only IP which can address this problem to make it efficient on a large scale, on a big events, on the big deployments. Another topic is how to carry all the signals from many cameras back and forth to remote studio, in order to not to bring the complete team which is doing the production on site, which is usually associated with a big travel cost and shipping cost of the equipment, etc. Having in mind that the 2110 is not embedded protocol, where the time and information is delivered separately, this has an advantage of making possible to use the different parts of the signal on its own without need to carry the complete feed. But it also will require the precise synchronization between feeds. So this will imply some challenges, and that is why PTP is very much is needed for the 2110 workflows. But at the end, the 2110 protocol is a very nice and very beneficial evolution of the standards to address modern broadcast workflows. There's no embedding and de-embedding. You can take the essences, you need like audio, ancillary essences, and to process it on its own. It's compatible, backward compatible with many broadcast wide use standards like IS67, MADI, etc. It also supports natively all the modern standards like UHD and HDR. So as a summary, you can see on the screen what is 2110 in a nutshell. It's a set of RTP feeds which is carrying the different parts of the feeds. It can be audio or multiple audios, it can be video, ancillary data, and of course time and information to keep it in sync. On here in the video, I'm showing only raw and compressed data, but it's also the standard allows you to use the lightweight compression. So it's perfectly fine to save the bandwidth where it's needed to apply a compression. But in order to manage all these different feeds, I mean, you don't want to do it manually. There are too many feeds. It's too high risk of making a mistake. And also, in order to avoid single vendor proprietary solution, the industry come with what is called NMOS. It's a network media open specification, which I'm to build an API or to build a standard to manage IP media network, primarily 2110, but it also goes beyond. NMOS is quite wide spec. Not all parts are now in a stable phase and being accepted as a standard. I will talk today about ISO 4 and ISO 5 as two widely used and from my experience, is the most often used parts of the NMOS spec in order to manage the feeds between the facilities, 2110 feeds. NMOS spec includes also other parts I will not cover today, but including the target devices, audio channel mapping, so a lot of different stuff can be done through the NMOS APIs. But if you go back to the ISO4, and this is where we start, this is where it's actually begun. This is the way to define the device structure. So what is interesting, ISO4 define the basic things. They define the registration server. It's basically a database with devices available on the network. It define a device structure, including the node, device, sender, receiver, source, etc. It also define that the HTTP and the JSON is a base for this API. So that's a common protocol which is used in many different industries today. Just to give you an example of the camera and how it looks like from the ISO4 point of view. Like as a node, we have a camera, and this is a one device. One node may contain more than one device, as it will be, for example, with the X chassis. As a source, camera has a video generator and audio generator. So it basically can be two sources. Flow, it can support number of the video flows and the number of audio flows. And as a sender, so for example, this is if it's a modern camera, it has the Ethernet ports or like IP ports on the back of it. As a sender and receiver is actually virtual output ports coming out from the camera. All this information is being delivered to the database, and then the broadcast controller can use this information to build the flows. In order to build the flows, you have to use ISO5. The main purpose of this part of the spec is to define how you can connect sender and receiver. In order to do so, the sender and receiver have to go through the so-called activation phase. So this allows to make a schedule of the events. So it can be immediately, it can be now, it can be going later on, and so on. So in order to deliver information about the sender and receiver, ISO4 is using so-called SDP. So this is a file with all the information you can see on the screen now, like a source and destination IPs and what type of activation is going to be. Altogether, this allows to build a network with the different devices, with the cameras, microphones, the monitoring devices, and so on and so forth. And this allows to manage the flows in this network in an efficient way without having the mistake scheduling the flows, etc., etc. So this is what NMOS bring to the picture, to the industry. So I think this is very much about the NMOS, considering the time frame we have. So what we learned today. So the broadcast modern challenges include the complex workflows and new standards, which requires the modern standards. As one of the answers to this is SMPT 2110, which is carrying the audio, video, and ancillary feeds over the IP as OTP feeds, being synchronized, being compressed or uncompressed. And we talk about the NMOS, which is the specification to manage the connection in the broadcast networks. And we touch on base on the ISO4 and ISO5, which is a fundamental parts of the NMOS spec. So, is there any questions at this stage?
For now, we have no questions. Maybe at the end of the session, there may be some questions, Mikhail.
Yeah, okay, we can do it later. And then I would like to show the very last slide, and I would like to welcome the participants of the webinar to the appear.net blog, where quite soon there will be published the article about the IP trusted boundaries, the aspect which I did not cover on this, but it's a very important part of the IP broadcast network, is the security. So thank you very much for attention. And here I will hand it over to Tevelde. Tevelde, stage is yours.
Thank you, Mikhail.
Just give me a second.
Welcome to Roel.
Thank you. Okay, let me share my screen and then I will introduce myself. You can see my screen?
Yes, but maybe presenter modes. Maybe we can.
Yeah.
I have also a private question to you as well. Before, like Mikhail, I asked to Mikhail.
Yeah.
You know, I'm running. I'm a marathon runner, and most of our colleagues go to Kenya, Ethiopia. What's the reason? Do you?
I guess it's the environment in the highlands of East Africa. Maybe it will help with developing the high endurance, I guess, with the breathing and stuff. So that's probably the reason. I'm not an expert on this, but
Okay, thank you.
okay, can you guys see my presentation?
Yes.
Okay, thank you, Mikhail. My name is Tolde. I am a technical sales engineer at Appear. I'm working at Appear for the last 4 years. And I have been in the broadcast and telecommunication industry for almost 6 years now. So yeah, I will jump to the talk I will give today. So Mikhail has presented what are the current technologies in the contribution side of the broadcast in chain. I will focus on the distribution part of the broadcast chain, and specifically on the live transcoding for OTT service, or the adaptive bitrate streaming. So the title is Back on-prem for live transcoding. So in this talk, I will cover what is live transcoding, what is OTT, how is live transcoding using in OTT, and we will also cover the two major deployment scenarios for live transcoding, which is on-prem and cloud. Towards the end of the presentation, I will also talk about our solution, which is the NEO series, which is our recent software transcoding solution. So what is live transcoding? So live transcoding is a process of creating several profiles of the same service or the same video, in which each profile is tailored to different settings that allows operators and broadcasters to deliver their services in different qualities, depending on the network conditions and in the device type. So these multiple profiles are used for multi-screen streaming in an adaptive bitrate streaming ecosystem. So this is simply the live transcoding definition. One of the dominant or the common scenarios or applications where live transcoding is heavily used is the OTT, the over-the-top ABR streaming. So basically, over-the-top or OTT, as the name indicates, is a service provided by a broadcaster or an operator on top of an existing internet. It could be the public internet, for instance. And this is a service where different devices can access different services anywhere on any device. So when we dive deep to OTT, as I mentioned, it uses an internet connection to deliver a TV service, unlike IPTV, for instance, where you need a separate TV network to provide your services. It uses the IP infrastructure, the internet, the web browsers, and the HTTP protocol to deliver the services to different end devices. So that means there will not be any need for decoders or STB boxes to stream different services from mobile, from iPad or PC or TVs. So the main goal with OTT is to be able to provide different format videos that can be streamed on different end devices. And to see how the typical live workflow, how does the OTT achieve this, is I will discuss this workflow that you see here. So we are focusing on transcoder, but I want to give what OTT looks like. So as you can see, there are different parts in the OTT ecosystem. It starts with ingesting different services from satellite, from local feeds on IP or local playouts. So you feed those channels or services to your transcoder, and this transcoder, especially the live transcoder, changes the same service into, or prepares this service into different profiles of output. And it will send to this packager or origin, where it will prepare this for HTTP delivery over the internet. And the CDN, or the content distribution network, will mass distribute all these different profiles to the end devices through the ISP or your internet provider, basically. So as you can see here, different TVs, mobile or PCs will be able to access services on different resolutions and on different qualities, depending on the network condition as well. So this is what OTT is in a nutshell. So if we focus on what we do with the live transcoding, is you ingest these services over satellite or IP, then you do the live transcoding either on premise, where you can deploy your own servers, transcoding servers. You have your own experts doing all this configuration of hardware and software, in which you have the ownership of, or where you can put these transcoding servers in data centers, for instance, where you can manage and control the resource of this transcoding available transcoding resources. And this is very ideal for live channels where it is 24/7 live. This is very ideal because you have all the control. But also it requires a lot of expertise, a lot of technical knowledge and support in order to maintain the whole transcoding platform. The other option, which is the most recent option and widely popular, is also the cloud or the public cloud option. So in this case, instead of doing the transcoding on data centers or in a premise facility, you transport all the channels or services into a cloud over a private network or over the public network through different technologies. It could be SRT6. And then you transcode this in someone else's computer, like the cloud. It could be Amazon, for instance. And this is very ideal for ad hoc or for variable workload events, for instance. If you are producing events that will last for a short period, then this could be ideal. And this is outsourcing everything in the cloud. So this will allow operators to ensure high compatibility, because when you choose a certain public solution, public cloud solution, there are some, since everything is done in the cloud, it's more compatible with end devices. But this also could be expensive, for instance, for a long run. Over the long run, it could be expensive when you have channels running for 24/7 all year long. So this is how the typical live transcoding deployment looks like. So in addition to this, there is a report by BitMoving in which they show what the general understanding of this live transcoding is now, or where it is at this moment. So there was a research that was a survey conducted in 2022 to show the streaming industry where operators and broadcasters are doing their live transcoding. So as you can see in this chart, you can see there is a high percentage on the hardware encoder or transcoder on-prem appliance. There is also on-prem on software encoder, and we can also see that the numbers on the private and public cloud are a bit less compared to the appliance. So here we can see that operators and broadcasters are actually using both depending on the business plan they want to implement. So compared to the previous year reports, we see also a little bit of increase in the premise and the premise both on the software encoder and also on the hardware encoder. So this is to show that both the deployment scenarios that I mentioned before are still share the market significantly. So based on this, Appear has a solution for live transcoding on-prem solution. So based on the inputs, market inputs, and what is available on the market, we have NEO that offers a custom hardware, state-of-the-art HPC server technology. So this is a software transcoder based on a custom hardware, and this helps customers and our customers to deploy live transcoding with a less technical and deployment hassles, for instance. So it makes it easy for deployment. It includes a CPU and a GPU based compression for AVC and HEVC, and this is very flexible, very scalable on-prem solution, because it uses CPU and GPU on in a parallel fashion of transcoding. And it is very power efficient, and also this counts into the total cost of ownership that it is optimized total cost of ownership on-prem server transcoding. So this is our NEO solution. So I will discuss one of the customer use case we have recently based on our NEO. So initially, this customer of ours uses the AWS cloud to transcode, to do the packaging and origin, and to do end-to-end OTT service that I have discussed before. So as you can see here, from end to end, there is at the beginning of this, you have the Appear servers doing the live transcoding. So basically, this customer wanted to pull out the live transcoding part of the OTT ecosystem into on-premise, and then do the transcoding on their facility and transport this transcoded multiple profile IP feeds into the AWS. And then on the cloud, AWS cloud, you can do all the packaging, origin, add insertion, and all that functions, and make it ready for the end user to watch the services, basically. So in this customer case, you can see that the compatibility of our NEO solution towards the AWS, because we have to develop different AWS compatible features for our products. For instance, as you can see, there is a web DAV. It's a way to interface with the AWS in order to handle the videos. Also, we have WebVTT, integrated WebVTT. This is to handle the subtitles, for instance. And as you can see, also, we have a 10+1. We have deployed a 10+1 configuration where you have main 10 live transcoders and a redundant system for failure protection, basically. So you can see this also, the live transcoding is not only on cloud. So to recap this talk, live transcoding is an important aspect of the mass distribution of services to the end users. And we see from the survey and what we have as a company as well is on-premise transcoding is still very significant. All is not cloud. What customer wants to do with live transcoding, whether it's on-premise or on cloud, actually depends on the business model they want to pursue. Yeah, so this is what I had for today. Thank you. If you have any question, you are welcome.
Well, you had a graphic chart, and when we sum up, it's over 100%. I think some of the users were using software encoders and also this one.
Yeah. So this survey, that's a good point. So the sum here is more than 100% because some customers use hybrid. Some of them use hardware appliance on premise, software appliance, but also the survey. The participants, the video developers and the industry experts have answered on more than one options on these different categories. That's why it's more than 100.
Roel, you can, I think we have some questions and Q&A session. Maybe you can ask these questions to Mikhail and Roel there. Did you see Q&A?
Shall I ask the questions? Maybe you can do it because let me see.
Yes.
I don't see them. I don't see them. Maybe you can ask them.
Yes, question one is, this is a question from our audience. Is NMOS only possible way to use 2110? I think this will be going to answer by Mikhail, right?
Yes, the good question actually. And the answer is no. NMOS is the aim to build a common API to enable multi-vendor network and to easy integration in the multi-vendor network. But the orchestration system of choice of the customer, it's always up to the customer to choose it. And this orchestration system may support the vendor-specific API. So, for example, in a pure equipment, both are supported and possible. So we support NMOS spec, ISO 4, ISO 5, and we have our specific APIs, which allows to retrieve a little bit more than ISO 4 and ISO 5 allows to do so, but also cover the use cases of the NMOS. So no, the NMOS is not only way to control 2110, but then the downside of this will be the complexity integrating multi-vendor environment.
Okay, another question from our audience. Does Appear support a lot of remote production cases already?
Yeah, I can answer that, I think. Yes, we do. We have various cases. Actually, we recently announced a new customer case on our website. So I invite people to go to the website and check that out. That was for PSSI Global in the US that is using the Appear X platform for the Ultimate Fighting Championship. So that's a global sports league. That's a huge remote production application. Maybe I can also mention that why has this customer, but also the other customers chosen the X platform for remote production is I already mentioned some of the let's say the features or the high benefits of the X platform, but it's of course about flexibility and density, right? Because some of the live remote production applications are very dense, but also customers would like to invest in a platform that they can grow with, right? So they can grow with the existing platform. It's also important to have a small form factor because that saves money in power, obviously, but also in transport, shipping costs, etc., which is super important for remote production applications, right? Because they are going into cases and being shipped all over the world or the country. So you need to have a reliable platform, right? So I mentioned that earlier as well. It needs to be resilient enough to be transported and move around. And then the last thing, and that's maybe an obvious thing, is of course the high quality and the low latency, right? Because for remote production, low latency is super important. But this is the last case that we announced on our website. We can share other cases as well. I don't know. I think there are probably others, but yes, we have various deployments on remote production, and yeah, this is really taking off.
One more question from our audience. Do I need a PTP to run 2110? Is there a way to avoid? Maybe well, who will answer this?
Yeah, I mean, I can answer this. No, I mean, the PTP is mandatory because for the 2110, because 2110 protocol assume external timing. So 2110-10 feed need to carry the timing, and all the feeds need to be synchronized. In order to achieve this, PTP is used. If you don't want to deal with the PTP synchronization complexity between the different sites, then it is possible to use transfer stream feeds, either carrying the contribution AVC, HEVC codecs with ultra low latency, or to carry JPEG access encapsulated into a transfer stream, which will allow to achieve almost a frame grade latency in the transfer stream domain, but will let you avoid using and implementing the PTP. For example, to bring the content from remote locations or to connect the two facilities like going back and forward. Both protocols are supported by the Appear products, and we have customers who prefer the one way or another, depends on the use case they have.
Thank you, Mikhail. And I think, Roel, this question comes to you about AWS integration. Does Appear support an AWS integration? And another question is, apart from AWS, which all cloud media can be supported?
Yeah, so as I try to show on the customer use case, the answer is yes. The short answer for AWS integration, we have customers integrating our live transcoding solution to AWS packaging, for instance, the media connect, and also the media package, AWS media package, and also AWS media tailor for ad insertion handling. So AWS, yes. Apart from AWS, we are also compatible, or we also are supported for Akamai, for instance, with our HLS push. We have integration with Akamai. We are actually Akamai Media Live certified as well. So yes, in addition to AWS, we have Akamai. But also we are constantly trying to improve and work on our live transcoding solution, so we can be as compatible as possible with the most common cloud solutions.
Thank you. I think these are all questions. Thank you, guys. Now I'm closing the session. Ladies and gentlemen, thank you for your joining us today to explore the transformative potential of live production and distribution over IP and backbone on-prem for live OTT transcoding technologies and the visionary work of Appear. I encourage you to connect with their team to explore how this groundbreaking solution can revolutionize our business, your business. Embrace innovation, seize new possibilities, and together let's shape a future of progress and growth in the broadcasting and OTT DTH sectors. Thank you once again and have a fantastic day. Go ahead. Thank you, guys, for
Thank you very much.
attending
Thank
this
you.
webinar.
Thank you very much for the
Thank you.
opportunity. It was nice session. Thank you.
Well, thank you for hosting in Appear sites. Well, Mikhail, thank you.
Thank you very much, team.
Bye-bye.
Bye.
Bye-bye.
40.